in a few days, it was meant to be today, weather has denied you, you're going to send up some of your technology to the International Space Station because we're updating quantum research in space. Why? What is it giving people?
Well, first of all, thank you so much for having me, Caroline. And let me tell you a little bit about Infleqtion, just because that'll help inform the answer. So Infleqtion is a quantum technologies company, and we create a suite of products all based on these quantum cores. And inside these quantum cores live millions of atoms, and we turn those atoms into all sorts of products ranging from clocks to sensors, like the one we're sending up into space, to computers. And the reason that matters is because they can do things that classical technologies can't do, nor will ever be able to do. And so what we're doing is, in the case of sending this product up into space, is to replace some technology we put into space back in 2018 called the Cold Atom Lab. And what that is doing is doing experimentation on quantum, because you can actually experiment on quantum better in microgravity in space. And it's a proving ground for being able to sense what's happening on the world's surface or under the surface with extreme precision, or sense what's happening around to other spacecraft in space. And the level of precision that we can bring with quantum is orders of magnitude bigger than what you can do with classical technologies.
ISS. Its role is changing.
It is.
So where next? There's a proving ground for the tech.
Yes.
There's a proving ground for where you put that tech.
Correct. So in 2018, actually, Christina Cook, the astronaut who's currently on Artemis 2, installed our tech on the ISS, and they've been working to make sure this technology works on the International Space Station, so a human in the loop. Next stop is to put what we call our quantum gravity gradiometer into a satellite, which we're working with NASA to do. And so we're taking it from research in space to an application in space. And what that quantum gravity gradiometer will do as it circles the Earth's orbit from a satellite is sense changes in gravity on the Earth's surface with extreme precision. And you can infer all sorts of interesting things by the way gravity changes. So you can infer the depletion of aquifers underneath the Earth's surface. You can see what kind of things are being built underneath the Earth's surface. So all sorts of very interesting use cases.
Hey, Matt, go ahead and hold that up again, because Bloomberg Tech executive producer Jackie Lopez wants to see it. I think it's really important to... Let's go back to basics. This is not about putting the quantum computer into space. It's about putting the sensor into space.
That's right.
Go back to basics for our audience and explain that for the data inputs.
So absolutely. So there are two broad technologies that quantum can create. One is called a quantum sensor, and the other is called a quantum computer. Quantum computers are not yet useful. They will be very useful in the not too distant future, but quantum sensors are very useful today. And so what we do, it's the same underlying technology, the same componentry inside, but we can turn those atoms into extremely precise sensors to sense what's happening on the Earth's surface and the world around you. So in the case of what we're sending up into space, it's indeed a quantum sensor, Ed.
Matt, real quick, who's the launch provider? Who puts you to orbit?
So we're on a SpaceX vehicle, and then the spacecraft itself is made by Northrop Grumman.
And real quick, what's that like, that experience as a customer, the door being opened to be able to get into orbit?
It's incredible. I mean, we wouldn't be able to get this technology up unless the work that SpaceX and other folks are doing to make launches less expensive. And so our partners at NASA have been wonderful in getting that all set up for us.
And can I jump in and just ask very briefly, from quantum clocks to what? Because everyone's like, when is there going to be a really useful quantum computer? IBM saying 2029. Is that your business model?
So the business model is, you might say, what the heck does a clock have to do with a computer? They seem very different. Well, in quantum, they really aren't, because what we're doing is we're taking advantage of the quantum mechanical principles of atoms, and then using those quantum mechanical principles, and with slight tweaks to what we're doing with lasers, can turn it into a clock, or in more, call it precise use cases, turn it into a computer. And so the clock is in many ways a mini version of the computer. Your question, when will computers be useful? The timelines keep coming in, and the announcement that Google made on Q-Day being here earlier and earlier, and Q-Day is the day that we can break modern encryption with a quantum computer, getting pulled into 2029. Our view is that quantum computers will start to be useful in the year 2028.
Right.
And that is at we'll get into what qubits are, but when you can get to 100 logical qubits, you can do interesting things with quantum computers.